Hello everyone, myself Srivalli, working as an assistant professor in the Department of Cybersecurity and Data Science in MLR Institute of Technology. So today we are going to discuss logical equivalence by using the replacement process. So in the previous class we have discussed about what is logical equivalence and how to represent this logical equivalence by using the truth table. So in this session we are going to cover by replacement process. If you want to solve the replacement process, first you need to understand the laws of logic. Means here you need to by heart the formulas of laws of logic. So here the same definition it will be there for the truth table and the replacement process, only the process is different here. So here if m comma n are two compound statements and if the truth values in the last column of m are same as that of truth values in the last column of n, so then we can say that m is said to be logically equivalent to n. Means let us suppose here we have m is one compound statement and n is called another compound statement, and these are said to be logically equivalent if they have the same values. So in this replacement, how you can solve this? So we will consider this m as here LHS and the second one will consider it as RHS. And this LHS first we'll consider and we will be solving until we get the RHS. Means here we'll consider this LHS, that is one compound statement. Let us suppose we have negation P or Q. And this one you have to solve by using the laws of logic that you need to by heart. So until you need to get here, you need to solve until you get here RHS. So this is the process of by using the replacement process. So before going to solve the problems, first let us see the laws of logic formulas. So here we have the laws of logic formulas here. Those are, so first one is we can say that identity law. So here identity law means P and T is equivalent to P and P or F is equivalent to P. Means whatever the true statement or false statement you are considering with the P statement, always you will get the same statement, that is P. And here next we have domination law. So here P and F is always equivalent to F. P or T is equivalent to true. Next we have idempotent law. So here the same statements you will be applied in between or and the answer also you will get it as P statement, the same statement you will get. Next we have double negation. So here negation of negation P is always equivalent to the original statement P. Next we have commutative law. So that is here we are applying here and between the P and statements, and even this P and Q is always equivalent to Q and P. So in the previous session, the truth table method, we have seen P and Q and Q and P or P or Q and Q or P. So always they are same. That's why we are considering it as both are equal. So next we have associative law. So for this associative law, you will be having three variables, but here in the three variables also, we will have the same connective. So that is P and Q and R. So here P and Q and R is always equivalent to P and Q and R. Means we are giving the brackets for P and Q in the left side and we are giving the brackets to the Q and R. So means even if you change also, the meaning will not be changed. That's why here we are taking that both are equal here. So next we have P or Q or R is logically equivalent to P or Q or R. So brackets here we have given P or Q and here Q or R. This is called associative law. Next we have negation of P and Q is equivalent to negation P or negation Q. This one we can write it as here De Morgan's law. So here this is De Morgan's law. Negation of P or Q is equivalent to negation P and negation Q. And next here we also have distributive law here. So that is distributive law means P and Q or R is logically equivalent to P and Q or P and R. Means this end operator is distributed to both the P variables. So here that is P and Q and this R will get in the middle here and P and R. So not only this, you can also do vice versa P or Q and R. So this is P or Q and P or R. So this is distributive law. So next here we have De Morgan's law, that is negation of P and Q is equivalent to negation P or negation Q. Means we are applying the negation for both the variables after releasing the bracket. So whenever you release the brackets and if you are applying the negation, this AND will become or will become AND. This is called De Morgan's law. Next we have absorption law. P and P or Q is always equivalent to P, or P or P and Q is always equivalent to P. So next we have a negation law. So P and negation P is always equivalent to F. P or negation P is always equivalent to true. So this is called laws of logic that we need to by heart if you want to solve the given question by using the replacement process. And these are already all proven statements. That's why we are considering it as laws of logic. So not only this, along with this laws of logic, we also have three standard formulas. Those are P implies Q is logically equivalent to negation P or Q, and P by implies Q is always logically equivalent to P implies Q and Q implies P. And we also have the next formula, that is P or Q and R or Q is logically equivalent to P and R or Q. So these are the three standard formulas along with the laws of logic. We need to by heart all this if we want to solve the problems by using the logical equivalence by using replacement process. So here let us see some problems by using the logical equivalence here. So the question is here, use the logical equivalence and show that negation P or negation of P and Q is a contradiction. So let us write here negation P or negation of P and Q. So this is a given question and we need to solve until we get here F. So here let us suppose here if you observe, so here let us solve some problems based on the logical equivalence by using replacement process. And the question is here, use the logical equivalence and show that negation of P or negation of P and Q is a contradiction. So let us write the given question here. Negation of P or negation of P and Q is a contradiction. Means just we are noting the LHS question here. Now if we observe this question here, so negation of this P or this total I am considering it as Q, then you can write it as negation of P or Q. And we have the formula for this. So that is called negation of P or Q is logically equivalent to negation P and negation Q. Means we need to apply the De Morgan's law. Negation of P or Q is logically equivalent to negation P and negation Q. So this is the formula we need to apply by using the laws of logic. So if we apply the laws of logic, it will become here negation P and negation of P and Q. So this is the formula here. By using laws of logic, you will get negation P and negation of P and Q. So now for this again, we have the formula for the double negation. Negation of negation P is equivalent to P. So just apply the formula, then it will become negation P and Q. So the formula which we have used is negation of negation P is equal to P. This is a De Morgan's law, and also here this is a double negation law. Now here negation P and P. So as we have the two connectives same, you can apply the associative law. Associative law is here P and Q and R is equivalent to P and Q and R. Means you can group any pair of variables if you have the same connective. So negation P and Q. So negation P and P, if you see the formula here, so P and negation P or negation P and P, we have F, which is called negation law. So simply you can apply here F and Q. And here F and P is F by using the domination law. Then you will get F and Q is F. So here we have applied P and negation P is equivalent to F, which is called here negation law. And here we have applied P and F is equivalent to F, which is called here domination law. And finally we got F. F statement or false statement is also called it as here contradiction. So here, as we got this is a contradiction here, then we can say that this negation of P or negation of P and Q is logically equivalent to this contradiction. So in the same way, let us consider the next example also. So the example is prove that negation of P implies Q is logically equivalent to P and negation P by using the equivalence formulas without using the truth table. So here without using the truth table is nothing but by using the replacement process. So here let us consider this is LHS and let us consider this is called RHS. So consider LHS here, negation of P implies Q, and this is LHS and you need to solve until we get here RHS. So negation of P implies Q. So we can also write P implies Q by using the standard formula negation P or Q. So just apply here negation of negation P or Q. So in this, here if we observe, this is negation of P or Q by using the De Morgan's law here, negation of negation P and negation Q. Just we have applied here De Morgan's law, negation of P or Q is equivalent to negation P and negation Q. Now, negation of negation P is what here? P by using the double negation, negation of negation P is equivalent to P, and here and negation Q. So we can stop up to here. Why? Because we already got RHS here. So we have taken LHS and we have solved until we get RHS. Then we can say that negation of P implies Q is logically equivalent to P and negation Q. So in the same way, consider the next problem also, third problem. Let us consider prove that P implies Q or is logically equivalent to P implies Q or P implies R. So here not only we have to consider LHS, that you need to understand that we can take RHS and you need to solve until we get LHS. So let us suppose here I am considering RHS, that is P implies Q or P implies R. I have considered here RHS. So P implies Q, by using the standard formula I can write it as negation P or Q, or P implies R. This is also standard formula, negation P or we can write. So if we observe here the same connectives are there, then you can group any pair of variables based upon the output, means based upon the LHS. Why? Because we have taken RHS here, you need to solve until we get LHS. So based upon the LHS answer, we need to consider as we have the same connective. So negation P or negation P, here I am considering grouping the variables, or Q or I am considering. Now negation P or negation P, simply you can write it as negation P. Why? Because P or P is equivalent to here. So if you observe P or P is equivalent to P, which is called idempotent law. So in the same way here I am writing negation P or negation P is negation P or Q or. So here I am just representing this is negation P or Q. This total I am considering it as Q. If you have negation P or Q, we can write it as formula, standard formula P implies Q. So by considering this one, I can write it as here P implies Q or. So P is as usual here we have, and Q or. Q or means here Q is in the place of Q or. So P implies Q or, which is our LHS. So this is called LHS. So we have taken RHS and we have solved until we get LHS. Then we can say that P implies Q or is logically equivalent to P implies Q or P implies R. So next let us consider another example by using the replacement process, that is P implies Q is logically equivalent to negation Q implies negation P. So this is a question. So here you can consider anything, LHS or RHS, but you need to get the other one, whether it is RHS or LHS. So let us suppose here, let us consider the question negation Q implies negation P. Means I have considering RHS, negation Q implies negation P. So here in this question, if you observe, this is in the form of standard formula P implies Q. So P implies Q is negation P or Q. So here you can write negation of negation Q or negation P. So negation of negation Q, by using the double negation, you will get Q or negation P. And by applying the commutative law, you can write it as negation P or Q. I am just interchanging the variables by applying the formula commutative law. Now negation P or Q. And this negation P or Q, I can write it as simply P implies Q by using the standard formula. So then I got LHS here. So I have taken RHS and I have solved until I get LHS here. So then we can say that P implies Q is logically equivalent to negation Q implies negation P. So like this, we can solve the truth tables and also we can also solve the replacement process problems. So for the truth table, you need to solve here LHS and RHS, and if the same values we are getting here, then we can say that they are logically equivalent. For the replacement process, first you need to by heart all the laws of logic along with the standard formulas. So if you are perfect in this, you can solve any type of question by using the laws of logic. So here we have solved all the 3 to 4 problems. So by this, we'll end the session here. So today what we have discussed is what is replacement process, what are laws of logic, and how to solve the problems, different type of problems by using the replacement process, that is by using the laws of logic. Okay, so by this we'll end the session. Thank you.